Okay, we're going to do a third and final day on lesson 10.2, which is measuring angles and arcs. The focus of today's work is going to be on looking at what radian measure is and how it's calculated, and then also look at how we can convert between the radian measure and the degree measures in arcs and in circles. Okay, so first of all, talking about what the idea of this radian measure is. All right, the definition radian is a unit of measure used for angles, and it's mainly just used in trigonometry. You won't do a ton with this. We will do some of the work that involves radians, but we're not going to do a ton. But we need to understand the concept here. Okay. Okay, now a radian is determined by the arc of a circle, and specifically, uh, the radian measure is the ratio between the length of the arc of a circle and the radius for that circle. That's how we generate a radian measure. So we take arc length and divide it by the radius for that circle. And radian measures are consistent based not consistent no matter what the size of the circle is. Okay. So for instance, if we had a 60-degree central angle, it doesn't matter how big the circle is, the radian measure for a 60-degree central angle is always the same, because the radian measure is a ratio of the arc length to the radius, rather than just looking at arc length solely as a degree measure. Okay, a circle has 360 degrees in it. It also would have 2 pi radians in it. Now, looking at the concept that a radian is the ratio of the arc length to the radius of the circle itself, then if we look at a complete circle's arc length, that would be the circumference. That's 2 pi r. And if you take 2 pi r, which is a complete distance around the circle, and divide it by a radius of the circle, the r's cancel and you get 2 pi. So in radian measures, the distance around a circle is 2 pi. In degree measures, the distance around a circle is 360. Now, the first example I'm going to take you through really is showing you the whole concept of radians and how it relates to the different size circles and how it's found. Okay, so this is our first example here. So they give us these circles, circle C, circle F, and circle J. And they're telling us that the central angle in each of these is 150 degrees. Now notice they all have different radii, I should say. So this first circle C has a radius of 3, circle F has a radius of 1, and circle J has a radius of 2. Okay, we're saying that all of those central angles are 150. Now, all central angles are the same, but according to what we do, are the arc lengths all going to be the same? The answer is no. This is obviously a lot longer of an arc length. So this distance from A to B is a lot more than D to F, and it's obviously more than G to H. So this is a much longer arc length. Okay, but in radian measures, all of these arcs would be the same. Now let's take a look at how that works. First of all, let's go ahead and find each arc length. All right, so we'll start with the length of arc AB. So how far is it from A to B traveling along this circle? That's arc length, right? Well, we find that by doing the central angle over 360 times the circumference of the circle. Okay, so our central angle is 150 over 360. Our radius is 3. So this right here will generate the length of this arc A to B. Now the 150 over 360 would reduce to 5/12 if you did it, just reduce that fraction itself. And then 2 pi times 3 is really 6 pi over 1. Okay. If we cross cancel and leave this in terms of pi, the answer is going to be 5 pi over 2. So the distance from A to B along this arc is 5 pi over 2 units, in this case millimeters. If I really want to know what that number was, I would do 5 times 3.14 and divide it by 2. And that would tell me how far it is from A to B. Okay, now how far is it from D to E? Obviously, it's not the same. It's a lot less of a distance. We calculate this arc length using the same concept, though. Central angle over 360 times the circumference 2 pi times, in this case, 1, because this radius is 1. So that's 5/12 times 2 pi over 1. Okay, simplify, and we get 5 pi over 6 millimeters. So the distance from D to E along this arc length right here is 5 pi over 6. If you did 5 times 3.14 divided by 6, it would give you that number. Obviously, it's a number that's going to be a lot smaller than our first arc. All right, let's find the arc length for GH. So the arc length for GH is going to be 150 over 360 again, same central angle. 2 pi times 2 now because our radius is 2. So if we simplify this, 5 twelfths times, this would be 4 pi over 1, cross cancel, and I get 5 pi over 3 millimeters. And again, if I really want to know what it was, 5 times 3.14 divided by 3 would tell you this distance. Okay, you can see these are all different numbers. Okay, they're all different numbers because they're all different arc lengths. You can see that. But let's talk about now the idea of radians. Okay, to calculate a radian, you take the ratio of the arc length to the radius for that circle. All right, so that's what we're going to do in this step. So we're going to look at our first one here, the length of arc AB, and we're going to divide it by the radius for circle C. Okay, so the length of arc AB is over here, right? It's 5 pi over 2, and we're going to divide that by 3. Okay, dividing by 3 is the same as multiplying by a third. Okay, if we multiply now numerators and denominators, we get 5 pi over 6. So the ratio of the arc length to the radius is 5 pi over 6. Okay, that was for the first one. Let's do the second one. So the arc length of DE over the radius of circle F. That's right here, right? Arc length of DE over the radius of circle F. So the arc length for DE is 5 pi over 6. The radius for circle F is 1. So 5 pi over 6 over 1 is 5 pi over 6. So that one's now simplified. That's the ratio of the arc length to the radius right there. And then do our last one. The arc length of GH divided by the radius of circle J. So the arc length of GH is 5 pi over 3. The radius of circle J is 2. So 5 pi over 3 divided by 2 is the same as 5 pi over 3 times a half. Multiply numerators and denominators, I get 5 pi over 6. So what do we notice in each case? Arc length, the ratio of arc length to the radius is the same in every case here. No matter what the size of the circle, the ratio of the arc length to the radius is always the same, and that's always the same for any 150 degree central angle. Doesn't matter how big or small the circle is, if it's 150 degrees in here, then the ratio of the arc length to the radius is going to be 5 pi over 6, no matter how big that is. And that's the idea of radians. Radians is more consistent concept. They're both consistent. They're both applicable. But this is the concept here. All right, is every 150 degree central angle would have a radian measure of 5 pi over 6, because radian measure is generated by the arc length to the radius. It's a ratio. It's not something you just generate on its own. So the last part here is for each circle, we can see the ratio of arc length to radius is 5 pi over 6. I think in your homework, they're going to give you like a multiple choice here. And the choice is this: the length of the arc intercepted by a central angle is always proportional to the radius. Okay. And that's for any size circle. So you're going to do some questions like this tonight. And I think exploring it like this really gives you some insight as to where this concept of radians comes from. Okay. Like I said, we're not going to do a ton with it, but it's good to understand. It's good to see. The last thing we're going to do is do some radian and degree conversions. And the rules are pretty simple. To convert degree measures to radians, you're going to multiply by pi radians over 180. This fraction is equal to 1. Now remember how I said 2 pi is all the way around a circle and 360 is all the way around the circle. Okay, if I put 2 pi over 360 and reduce it, I'd have pi over 180. So we just start with a reduced answer. So pi radians is halfway around the circle. 180 degrees is halfway around a circle. That's equal to 1 right there. Okay, to convert radians to degrees, we multiply by the reciprocal. 180 degrees over pi radians. This is equal to 1. Just like this was. Okay. So the homework will look like this: convert 240 degrees to radian measures, leave it in terms of pi. Okay, so 240 degrees to convert degrees to radians multiplied by pi radians over 180. Okay, now the reason is pi radians over 180. The reason we use this one rather than the other one is because look at our units here. We want to be able to cancel out units. So think of this as 240 over 1 pi radians over 180. The first thing we actually think of here is we cancel the degrees. The degrees are now canceled, right? Anything numerator denominator you can cancel. So the degrees are canceled. So that's going to leave my answer in terms of radians. The next thing we do is just simplify the number part here. 240 and 180 can both be divided by 60. We get 4 and 3. It said leave my answer in terms of pi. So if I multiply the numerators, what's left, the denominators, what's left, I get 4 pi over 3 radians. So a 240 degree angle is the same as 4 pi over 3 radians. And if you think about what that means I don't care how big the circle is. If you find the arc length of that 240 degree circle and divide it by the radius of that 240 degree circle, the answer will be 4 pi over 3 every time. Okay, let's convert another way here. Let's go 5 pi over 4 radians and convert it to degrees. Okay, when you go radians to degrees, you multiply by 180 over pi. So I got 5 pi over 4 radians times 180 degrees over pi radians. Now I left the units in there to show you that the first thing that cancels are radians. Numerator, denominator cancels. So I'm left with degrees, which is what we want. The second thing you'll always get is the pi's will cancel. That's a number, right? Pi is a number. I cancel it. I got the same top and bottom. Cancel it. So you're left with 5 fourths times 180 degrees. That's 225 degrees. So that's how we convert back and forth. Okay. So tonight's homework is you're going to get a few of those first style of questions that are multiple steps, but looking at arc length compared to radius and how that generates a radian measure. And then the second type of questions you get today is just converting degrees and radians back and forth. Okay. All right, guys, I'll let you get started.